Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a compilation of the whole topic of highest common factor and lowest common multiple. We will be going through a few examples from each of these videos: prime factor decomposition, highest common factor, lowest common multiple, and then worded lowest common multiple problems. If you would like to look at the full videos for each of these topics, they will be linked down below in the description. So I like to do this as a prime factor tree. So it says write 27 as a product of its prime factors. So I like to do this as a prime factor tree. So I'll put 27 or whatever the number is at the top, and then we'll split it into two. Now, there are two ways to do this. Either you just write down any two factors of 27 that you can think of immediately, and then break those down. I prefer to just go with prime factors. So if it helps to list a few of the smaller prime factors on the side, that's fine. So we've got 2, 3, 5, 7, not 9 obviously, 11, ... there's more than that. I tend to kind of use these. Normally my first port of call is either 2 or 3. I go, can I divide it by 2? If it's an even number, this one's not. Can I divide it by 3? Yes. I personally prefer to put the prime numbers on the left. So 3 is a factor of 27, but it is more specifically a prime factor, isn't it? Because at the same time it is a prime number. So 27 divided by 3 gives me 9 left. Then, because 9 is not a prime number, I'm going to break that one down further. This 3 on the left here, I'm going to leave it because it's already a prime number. I'm not going to break it down any further. Then I go to 9 and go again, okay, of my prime numbers over here, which one's divided into 9? Well, it's actually 3, and then another 3. And then you can go and circle the prime numbers, so they should be all the ones on the left. That's how I like to do it. So when it says write 27 as a product of its prime factors, well, we've broken it down into its prime factors. The word product means times, it means multiply. So you can therefore write it as 27 is equal to 3 times 3 times 3. Now, if they do then mention, leave your answer in index form, so like this, index form, that means powers. If you think about index, it's like indices, isn't it? In this case, 3 times 3 times 3 is 3 cubed, isn't it? That's the same thing. So just double check, does it say leave it in index form? In which case you do need to put it as powers. If it doesn't, then 3 times 3 times 3 is fine. And if we did in our calculator 3 times 3 times 3, you would get 27. So we've broken 27 down into its prime factors, into the prime numbers that divide into it. So we've got 180. This one's an even number, so I'm going to start by halving until I hit an odd number. So half of 180 is 90. I can half that again, which is 45. Now I've hit an odd number. So this one ends in 5, so I'm going to divide by 5. Sometimes there's multiple ways to do it, right? So for example, I'm going to divide that by 5, which is 9. Obviously there are other prime factors that go into 45, such as 3. You might get 3 and 15. That's also fine because at the end, it doesn't matter which order you get the numbers in, we're still going to get the same answer. So 9 is 3 and 3. I've got 2, 2, 5, 3 and 3. Just as an example, if we would still do it this way in terms of using prime factors, I might also start by dividing by 3 and go, right, well that's 60, and then I might divide by 3 again, which is 20, and then I'm going to divide maybe by 5, and that's 4, and then I get 2 and 2. It doesn't really matter which prime factors you use first if you've got multiple options, because overall, for this one particularly, you should end up with 2 2s, 2 3s, and a 5. Okay, it doesn't actually matter which order you break it down, as long as at the end you can write down the correct numbers. So 2 times 2 times 3 times 3 times 5, I'm just writing it in size order. Then index form would be 2 squared times 3 squared times 5. So I'm going to go through and do my factor tree for both. So in this case it's prime factors, so specifically prime numbers. So I know I always tend to start off with 2 if it's an even number, so 2 and 12. Then 12 divides by 2 again to get 6. 6 divides by 2 again to get 3. And those are all my factors that are prime numbers. So I've got 2, 2, 2, and 3. I'm just going to list them there. Then I do the same for 72. So I'm going to stick with the 2s because they're even numbers to half them. 2 and 18, 2 and 9, and then 3 and 3. Okay, so 72 is 2, 2, 2, 3, 3. So do that. So break these down into your prime factors. Again, if you haven't seen that video, go and check it out. I've got it linked in this video or down below in the description. So I've listed it here. You can see I've got 24 breaks down into the prime factors of 2 times 2 times 2 times 3. 72 is 2 times 2 times 2 times 3 times 3. And then we're going to draw some Venn diagrams. Now, obviously on your page in your exam, it doesn't have to look nice. Like, don't be getting your compass out. Just scribble some nice, rough Venn diagram circles. So obviously I'm just going to label each side. So 24 and 72. Doesn't matter which way around you put them. I just kind of put them in order of the question. Now, with Venn diagrams, you always start with the middle. What's in common? The middle is where they overlap, isn't it? So what do they both have in common? So if we have a look here, they both have a pair of 2s. So for every pair of numbers they have in common, you put it once. So that's 1, 2, and that represents both of these, okay? Then they've got another pair of 2s in common, so I'm going to put that again, once. And then they've got a third pair of 2s. Okay, so in the middle I've got 3 2s. I've not got 6, okay, just 3. So 1 for every pair that they have in common. Then they also actually have 3 in common, don't they? So I'll put 3 here. And then see how 72 has another 3 left over, so that goes on the 72 side. Whatever's left over that doesn't go into a pair goes on either side. So you quickly fill that out. Now this is a bit we need to remember. For the highest common factor, we're going to use the bit of the Venn diagram where it overlaps, the middle bit. So this bit here. So in this case, you can ignore that 3 on the outside. And what you're going to do is multiply anything together that's in the middle. So I've got 2 times 2 times 2 times 3. Now you can either work that out or put that in the calculator. 2 times 2 is 4, times 2 again is 8, 8 times 3 is 24. So the highest common factor is the middle bit of the Venn diagram. Okay, so our question is a little bit harder just because it is actually a 3-part Venn diagram. So you're going to have to break down all 3 of these numbers. Normally they choose one at the start that's a little bit smaller, like this 20 obviously is a much smaller number to break down. That's quite easy, 2, 2 and 5. Then 48, going to break down to the product of its prime factors as well, which does break down a little bit more. So we've got 4 2s and a 3. And then finally 120 is even, so I'm going to just keep going through the 2s until it's odd. And then 5 and 3. So we've got 3 2s, a 3 and a 5 for that. Okay, so just quickly break those down. So I've got them listed here. Now, you see here, obviously I've got 3 numbers. I'm going to have to draw a 3-part Venn diagram. So in this case, we're starting with this middle bit here. So what do all 3 of them have in common? That's why I like to list the numbers in order, because it's then quite easy to see. We've obviously got a 2. I'll write that down once. We have also got another lot of 2s in common. And then beyond that, there's not really anything in common, is there? So you can see the 5 for 20, they also have 5 and 120. So 5 will go here. You can cross them off. We've got a pair of 2s between 48 and 120, so that can go there. We've also got a pair of 3s. And then there's a 2 left over in 48 that no one else has. Okay, so then to find the highest common factor of this, it's just literally that bit right in the middle as well. It has to be where all 3 of them overlap in this case. So the highest common factor is 2 times 2, which is 4. Okay, so if you have a 3-part Venn diagram, it works exactly the same. Just make sure that you've got this middle bit correct, where all 3 of them overlap. So our last question is in a different format. Here we're actually given 2 letters, so we've got A and B. A is said to be 2 cubed times 3 squared times 5, and B is said to be 2 times 3 times 5 squared, and it says, again, find the highest common factor of A and B. So this one looks kind of more confusing, but actually, if we're going to use our Venn diagrams method, they've basically done the first part for us. They've already written whatever A is and whatever B is as the product of their prime factors. So we actually can skip the part where we did a factor tree. We don't need to do prime factor decomposition in that case. They've already done it for us. All we need to do is go straight into drawing our Venn diagrams and working it out from there. You don't also need to work out what A and B are as original numbers, because that would just be going backwards. So don't worry about that. Just take these prime factors as they are and we'll put them straight into the Venn diagram. So for the middle part, I'm looking for any numbers they have in common. They both have at least 1, 2, so I'm going to write that once. So I can cross out that 2 there, and we've already taken a 2 from the A, so that's now 2 squared. They also have a 3 each. So again, I can cross that out, and this one, and they also have a 5 each. Then the rest I'm going to put on either the A side or the B side. So A, we've got 2 2s left, 2 squared, isn't it? So 2 and 2. We've also got 3 left. And then B, we've got 1 5 left. So that's my Venn diagram filled out. Now to find the highest common factor, all I need to do is times together the middle part, isn't it? So that would be 2 times 3 times 5 in this case, which gives me 30. So the highest common factor of A and B is actually 30. So even though this one might look a bit more complicated, it's actually a little bit easier because you've already got half of the work done for you. And that's it for that one. So what you can do is you can break down both numbers into the product of their prime factors. So I normally start with 2, 3 and 2, so that one's 2, 2 and 3. 15 is a bit easier, 5 and 3. Now I've got it on the next page anyway. We're going to do exactly the same thing as we did with the highest common factor. So if you've seen that video, you'll know what to do. Any numbers that they have in common go in the middle. So if you look at this list, you see how they both have a 3. So I'm going to put 1 3 to represent that pair. Now they actually don't have anything else in common. So for the 12, there's 2 2s left over, and for the 15, there's a 5 left over. Now for highest common factor, we looked at just multiplying any numbers in the middle. For lowest common multiple, it's actually the whole of the Venn diagram now that I've filled it out correctly. So the lowest common multiple is all of that, and you multiply them together. So lowest common multiple in this case is 2 times 2 times 3 times 5. Now you might be thinking, well, isn't it just all these numbers times together originally? It's actually not, because you see how they had 2 3s, but I only wrote down 1. So whatever's in the middle is a pair. You're only going to write it down once. And then you just work that out. So 2 times 2 is 4, times 3 is 12, times 5 is 60. Okay, so same as we saw in the other video with highest common factor is they might actually give you 3 numbers if they want to make it harder. So we're going to do exactly the same thing. We're going to find the lowest common multiple of 18, 56, and 126. So I'm going to break them down into the product of their prime factors. So 18 is 2, 3, and 3. 56, break down into 2, another 2, 2 again, and 7. So 2, 2, 2, and 7. And lastly, 126 is 2, and then 7, and 3, and 3. So 2, 3, 3, and 7. Okay, so to break them all down, we've just got 3 numbers now instead of 2. As you can see, I've listed them here. Now, filling out the Venn diagram, obviously now we have a 3-part Venn diagram. I'm going to fill out the middle bit first. So what do they all 3 of them have in common? Well, they all 3 have a 2, don't they? So that goes in the middle. They don't all have another number that's in common. So looking at the 18, we've got 2 3s and so does the 126. So between 18 and 126, I've got 2 3s, okay, because there's 2 pairs and a pair here and a pair here. With 56 and 126, I've got 2 7s. So that's a pair of 7s, so 1 7 there. And then 56 just has 2 2s left over. So that's my Venn diagram. Now, as we said, the lowest common multiple is multiplying all of those together. In this case, though, remember, it kind of looks like I've got 33 there. Obviously, it's not. So just remember that it's 2 3s and not 33. So I've got 2 times 2 times 2 times 3 times 3 times 7, which again, I'll put in the calculator. And that gives me 504. Okay, so again, even though it says the lowest common multiple, the key is the word multiple. Okay, multiple is going to be bigger than your biggest number here. Okay, so it was going to be 126 or bigger. So don't think of it as the fact that it's like the smallest number that goes into them. No, that's a factor. The multiples are the times tables. So it's going to be bigger than your biggest number. And obviously in this case, I definitely didn't want to have to write out 3 lots of times tables that I don't know, especially not 18, all the way up to 504. So this is our last question for lowest common multiple. It looks a bit different to the ones we've just done. However, if you have seen the highest common factor video, you'll have seen something similar to this at the end of that one too. So we're given 2 letters here, A and B, which represent bigger numbers, right? They've said that A is equal to 3 squared times 7 and B is equal to 2 times 7 squared. Now, we don't need to work out what A and B actually are as original numbers, okay? That's not very helpful in this case. We're just asked to find the lowest common multiple of A and B. So all we need to do is just carry on with that method and just skip straight to filling out the Venn diagram. So the things that they have in common, they both have 1 7 in common, don't they? So I'll put a 7 in the middle, and that's it. So for A, we've got 2 3s left over, and for B, we've got a 2 and another 7 left over. Now, to find the lowest common multiple, we have to multiply together the whole of the Venn diagram, which means we have to do 3 times 3 times 7 times 2 times another 7. And that actually gives me 882. So that is the lowest common multiple for A and B. Again, we don't need to work out what A and B are as original numbers because that would just be going backwards. They've already given us the prime factors, we just need to carry on from that step in the method. And that is it. So, these questions don't normally mention lowest common multiple, but it'd be good to recognise the different styles and types that are actually the same thing. So, quite a common one is when you have some trains or some buses or something like that. In this case, I've gone with trains. So, for example, 2 trains both arrive at a train station. Train A arrives every 16 minutes. Train B arrives every 24 minutes. So you're looking for some kind of question where some type of event is happening every so often. In this case, it's trains arriving. It could be buses leaving a bus stop. Sometimes I've seen where they've said every so often different colour lights flash, things like that. It's all the same thing. We're not going to go through in detail how to find the lowest common multiple. We're just going to apply it straight to these questions. If you want to look through how to find lowest common multiple just in general, I'll link the previous video here and it's also down in the description. So, now that we know that we've got 2 different trains, they both arrive every so often, one every 16 minutes, the other every 24. The question is, if both trains have just arrived, after how many minutes will both trains next arrive at the station? At the same time, basically, is what we're saying. So, do you see how that's basically lowest common multiple? We're saying, right, every 16 means the 16 times tables, every 24 means obviously the 24 times tables. If they both just overlapped, they both just arrived, when will be the next time? So it's kind of like the next point in which both of their times tables overlap, i.e. the lowest common multiple. So again, there's 2 ways to do this. Either you can just list out the 16 times tables, list out 24 times tables until you get one that overlaps. Or we can use the Venn diagrams method, which is a bit more of a guarantee that we won't make any mistakes. So I'm going to use that method today. So I break down 16 into the product of its prime factors. So I can just go with 2, 8, 2 and 4, and then 2 and 2. And for 24, again I'm going to use 2 to get 12, 2 again to make 6, 2 again to make 3. So those are all my prime factors for both numbers. Then we need to get the Venn diagrams. Filling in my Venn diagrams, I first do the overlap, so whichever pairs of numbers I have. I've got a pair of 2s here, so that will go in once. I've got another pair of 2s, so twice, and a third pair of 2s, so 3 times. Then left over, I've got a 2 on the 16 side and a 3 on the 24 side. To find the lowest common multiple, I need to multiply together everything in the Venn diagrams. So the lowest common multiple in this case would be 2 times 2 times 2 times another 2 times by 3. Which gives me 48. So what we're saying is that in this context, 48 minutes, both trains will arrive at the train station. Now they've said after how many minutes will both trains arrive, so that is just the answer, after 48 minutes. So that is it, exactly the same method as normal lowest common multiple, but just in a different context. Okay, so our final question now actually has 3 different options. So here we have, there are 3 different colours on a string of lights. Blue lights flash every 8 seconds, green lights flash every 12 seconds, and red lights flash every 15. How often do all 3 coloured lights flash at the same time in an hour? So again, we're finding the lowest common multiple, but now of 3 different numbers. So I need to do the product of prime factors for all 3. So the 8 is 2 and 4, and then 2 and 2. 12 is 2 and 6, then 2 and 3. And 15 is just 3 and 5. We get our Venn diagrams, but now we're obviously going to have 3 circles. So we start off with the very middle, anything that all 3 of them have in common, in this case actually nothing. Then I move out to the other overlaps between each 2, so between 8 and 12, we've got 2 pairs of 2. Between 12 and 15, we've got a 3. And between 8 and 15, we have nothing. There we go, you can cross them out to see which ones you're missing. So we've got an extra 2 for the 8 and we've got an extra 5 for the 15. And again, lowest common multiple is when we multiply together everything in the Venn diagram. So we will have to do 2 times 2 times 2 times 3 times 5, which gives me 120. So this one's in terms of seconds, that's every 120 seconds, which for this case is actually quite nice because that's basically every 2 minutes, isn't it? If we want to convert from seconds to minutes, we have to divide by 60. So that's every 2 minutes. Now they've asked us how many times do all 3 coloured lights flash at the same time in an hour. Well, obviously we know there's 60 minutes in an hour. So I'm going to do 60 minutes divided by 2 minutes, and that gives me 30 times. So there's my answer for that one. So thanks for watching this video. That was a summary of everything you need to know for highest common factor and lowest common multiple. Again, if you would like to check out any of the full videos in more detail, they will be linked down below in the description.